Hello, and welcome to our VOTW presentation. We are A301, Paper Planes in Space, and the members are Ayush, Ami, Harrison, Jamie, Daniel, and Willis. The vehicle of the week we will be introducing is the Vega rocket, developed by the European Space Agency. First, we will show you a short clip of its launch.
5, 4, 3, 2, 1, top. Allumage P80 et décollage DK17, CO Renew et Taranis. Propulsion est nominale. Tous les paramètres à bord sont normaux.
So, what is Vega? Vega is a medium-sized launcher which its development began in 1998. Due to the changes in the original plan, the first launch was delayed to February 2012. Its main objective was to send smaller satellites such as CubeSats to lower Earth orbit with reduced cost. It can carry multiple satellites at once according to their sizes and mass. It has four-stage structure being 30-meter tall and 3-meter in diameter.
The first stage's P80 motor incorporates new technologies such as composite filament wound case, low-density thermal protection, new nozzle bearing, and low-cost material for the nozzle and consumable igniter that has increased the performance of the booster, which enables a reduction in launch costs. The second stage's Zefiro 23 model is a new stretch 24-ton solid rocket motor based on the Zefiro 16 model. It employs a lightweight carbon epoxy case, low-density EPDM-based thermal insulation, HTPB1912 composite propellant, and flexible joint nozzle. Combustion pressure and maximum thrust are 95 bar and 1,122 kilonewtons respectively. The third stage holds the 10.5 tons Zefiro 9A model, which has similar structural specifications to the Zefiro 23. It is an updated model of the Zefiro 9, incorporating a new nozzle design and optimized propellant loading. Combustion pressure and maximum thrust are 67 bar and 314 kilonewtons respectively. The upper stage, AVUM, consists of APM, the propulsion module, and AAM, the avionics module. Orbit circularization, empty stage deorbiting, and roll control before payload separation are roles of the upper module. The upper composite holds the payload adapter and fairing. Vega's avionics are adapted from existing hardware to reduce costs. It has 4 subsystems: power supply and distribution, telemetry, localization and safeguard, and flight control and mission management. To comply with launch safety requirement, the safeguard is fully redundant.
The performance. As introduced earlier, the ESA Vega is a 4-stage rocket. The first 3 stages, P80, Zefiro 23, and Zefiro 9, are solid propellant rocket, and the 4th stage, the Attitude Vernier Upper Module, AVUM, is a liquid propellant rocket. Stage 1 holds 88 tons of propellant, which produces average thrust of 2,200 kilonewtons. Stage 2 holds 24 tons, producing 871 kilonewtons. Stage 3 holds 10.5 tons to produce 20 kilonewtons, and the last stage holds 0.55 tons to produce 2.42 kilonewtons of thrust. The AVUM also can be restarted up to 5 times, allowing multiple payload transport to different orbit. The Vega is able to carry payload between 300 to 2,500 kilograms depending on the type and the altitude of the orbit, and the benchmark for Vega's launch is 1,500 kilograms of payload to a polar orbit at an altitude of 700 kilometers. It also has a system called Small Spacecraft Mission Service Dispenser, which allows for continuous transport of small satellite. A launch in 2020 had Vega delivering 53 satellites into 2 separate sun-synchronous orbit. Up to date, the ESA Vega completed 15 successful missions.
As Tianmei mentioned in the previous slide, the application of those new materials technologies increased the performance of the boosters, which reduced the cost of the launches. The extensive capabilities of Vega are made possible by the Vega Secondary Payload Adapter, VESPA, and the Small Spacecraft Mission Service, SSMS Dispenser, The Vespa allows the Vega launcher to carry a main satellite of 1,000 kilograms on top, a secondary satellite of 600 kilograms, or several small satellites totaling 600 kilograms in the internal cone. Vega's upper stage is capable of performing multiple firing strategies to release satellites into different orbits. In flight number 2, by using the Vespa, 2 satellites were delivered into 2 different orbits by involving a change in inclination, whereas the SSMS allows the possibility to maximize the number of small and light satellites on each mission, providing an affordable cost to each rideshare customer. Furthermore, the SSMS dispenser also provides flexibility as it can be assembled very close to the launch date. In the mission number 15, VB15, where 53 million satellites were progressively released into 2 separate sun-synchronous orbits. And here is the video of how SSMS works.
With the technologies and modules explained earlier, the Vega has launched multiple satellites and spacecraft into orbit. Here are some of the examples. The first one is the AAE251. This device is launched in 2013 into low Earth orbit by the Vega. It is used to take images and download data of Estonia. The second satellite is Proba 5. This satellite is used for monitoring vegetation of Earth and it was launched in 2013. The other satellite shown here is a LISA Pathfinder. This satellite is used to detect gravitational waves in space, and it is launched by Vega in Quora, French Guiana.
Let's take a look at the future. The future of the ESA Vega is a bright one, with new and improved versions of the Vega to be released soon. One of the improved versions, the Vega C, is set to launch in 2021. The Vega C is capable of accommodating dual loads of greater than 400 kgs each, with a total payload capability benchmark of 2200 kgs as compared to the 1500 of the current Vega. It is also capable of return missions. A variant of the Vega C is the Vega C Lite, which excludes the first stage solid propulsion engine from the Vega C. It is designed to transport small loads of a few hundred kgs. An implication of this would be to carry goods to and from the International Space Station. Another enhanced version of the Vega would be the Vega Evolved, or the Vega E, whose maiden flight is scheduled for 2024. It has improved versions of the third and fourth stage engines from the Vega C. It is also a more flexible variant and aims at using the next-gen green propellants as fuel. The list of countries participating in the development of Vega C can be seen on the slide, along with the pictures of the Vega, Vega C, and Vega E. Here is a picture of the Vega C and the Vega E, along with potential payloads that they could be carrying simultaneously.
To conclude our presentation on the ESA Vega launcher, the Vega launcher has enabled launches of multiple satellites into Earth's orbits from the time it was first launched until today. Although with multiple launches, it also raises a concern of the compilation of space debris that could become a problem in the future. Despite that, the ESA is trying to improve the Vega launcher with its vast enhancement of propulsion technology. This makes the ESA one of the leading space industry in the world today. Specifically for the Vega launcher, it is unique because of its cost-effective method of launches. That sums up all of our presentation on the ESA Vega launcher. Thank you for listening.